Welcome to the course W8691 Embedded Systems. This is the core paper for 4th year E&I. First topic, what we are going to discuss is Introduction to Embedded Systems. First, we should know what is embedded systems. Embedded means something that is attached to another thing. An embedded system can be thought of as a computer hardware system having software embedded into it. That is, the hardware should be there and a dedicated software should be embedded in the same system. Then we can call it as an embedded system, and the system should serve for one application. Then we can call it as an embedded system. So an embedded system can be an independent system or it can be a part of a large system. An embedded system is a microcontroller or microprocessor based system which is designed to perform a specific task. As I already mentioned, it is designed or its purpose is to solve a particular task. So that is going to be an important difference between the ordinary computer and the embedded system, because in the ordinary computer also we have software, we have hardware. In embedded system also we are going to have a hardware and software, but this is designed to attain or to accomplish, to complete a specific task. Then we can call that kind of system as an embedded system. For example, a fire alarm is an embedded system. It will sense only smoke. It's not going to do other work at all. Your software is going to be there, your hardware is going to be there, your sensor part is going to be there. As soon as it's going to sense the smoke, it's going to inform the hardware part, and hardware part is going to do some other necessary steps. Next, components and characteristics of embedded systems. Actually, embedded system has three components. It has hardware, it has application software, it has real-time operating system or TOS that supervises the application software. This is very important point. That is, RTOS is going to be an important part of an embedded system, which you are not able to see in the normal computers based systems. Okay, hardware is going to be there, application software is also going to be there, but RTOS is available in embedded systems. That is because it's going to do some real-time work. So definitely we need a real-time operating system which is going to supervise your application software. And what are the characteristics of embedded system? Actually, this is an important question. The detailed notes is also going to be uploaded in Moodle. So now I'm going to just explain, but the theoretical notes is going to be uploaded in Moodle. Characteristics, it's going to be single function. That's again an important one. Most of the embedded systems is going to be a single function, or it's specifically designed to do a specific task and tightly constrained. That is, constraints are going to be more because this is going to deal with the day-to-day product of hardware and software. So definitely the constraints is going to be much more complex, and it is reactive and real-time. It is based on the real-time values, and it's going to be reactive. Based on that, it should take some actions, and accordingly it should act. So therefore, this is going to be a reactive and real-time. And of course, it's a microprocessor. It may be a microprocessor or microcontroller. Obviously, what is a microcontroller? Yeah, microcontroller is also going to have a microprocessor with some external and internal devices. We can call it a way. So the basic is going to be a microprocessor, and obviously it's going to have memory, and it's connected. All the ports is going to be connected, and hardware and software systems. Obviously, this is going to have hardware, and particular programmers. The software is also going to be there. Then when we can able to program the embedded system. Next, the next is black diagram of an embedded system. It consists of the processor. The processor is going to be the heart of the embedded system. Then instead of processor, we can use the ASIC and ASIC, that is application specific integrated circuit or application specific integrated processor. Then memory, analog and digital input output systems. The analog input output is used to gate and read the analog signals from the physical systems, because the physical systems are capable of giving only the analog input. At the same time, it can able to respond only to the analog output systems, right? But for processing and all, we need digital, so that's why the conversion is also given. The conversion circuit is also kept on the same chip. Then RDF memory. Then when we can give our instructions, and our processor is capable of executing the instructions, then the result can be stored on the memory itself for further processing. Okay. And what are the advantages of embedded systems? It is easily customizable. That is, I can able to change it for particular. It is suitable for particular specific task, and it's going to consume low power, provided if the application is simple. And if the application is going to be a larger one, and your embedded system is a part of the larger system, obviously it's going to consume much power, right? Then low cost. Again, the low cost is also going to be based on the application, and it's going to be enhanced performance. In this sense, what is the meaning for enhanced performance? In the sense, it is capable of giving enhanced performance, provided if it is dedicated for a single task. Then obviously it's going to have disadvantages: high development effort. That is, for a particular specific application, I have to start from the scratch. I have to start from the microprocessor or microcontroller. Then I have to code it for particular applications. Then it needs much time and much knowledge. So high development effort is needed in order to design and develop an embedded system, and larger time to market, because so many embedded system companies are there, so many startups are there. So each and every design engineer can capable of doing the design for the same application. So there is a little scope for marketing, and the big companies can able to launch their product easily. If the startup is going to be there, then definitely that's going to take some time. Okay, but these disadvantages are already a part of any product, so we can just ignore this kind of disadvantages. But embedded system, obviously it's going to be the future of any small startups.